Hello everyone, in this video let's discuss how to solve the PDA construction problem very easily. So this is the part 2, part 1 video I will give in the description, you can see. So here the language is given and there will be two methods to solve this problem. One is using empty the stack method and another one is final state method. So in both the problems also we will do the minute change in the last step. So you must see up to the last step and it is a minute change. So I will show in the same problem. I will solve using both the methods in this problem itself. So now for the given language, first you write the possible strings. So what is the possible strings? Here a power n, b power n means the n value can be greater than or equal to 1. Greater than or equal to 1. So first let's check for n equal to 1. So it will be a power 1, b power 1. So how can you write the string for a power 1, b power 1? A one time, b one time. Next, if I change the value of n from 1 to 2, a power 2, b power 2. What will be the string? A, b, b. Next, if I change it to 3, it will be a 3 times, b 3 times. So this like only it will continue up to n elements. Now what we must do is, we must select a string. So I will be selecting this string. So after selecting the string, what you must do is, you must add epsilon in front of that. You must add epsilon. Now, so it will be included in this string and now we are about to start the problem. Now to solve the problem, we will be using one stack. We will be using one stack and that stack will be having z0 as its initial element. So in every problem related to PDA construction, you will be having a stack and its initial value will be equal to z0. So now if we consider this stack and start traversing from the first element, that is small letter a, so we must write the transition for each and every element. So how means? So now if you want to write the transition, we need the states. So how many number of states are required to solve this PDA problem means? So here, what is the language they have given? A power n, b power n. So what was the possible smallest string we produced? A, b. So its length is 2. Only A, B. So total its length is 2. So the number of states that you must use to construct this PDA problem is n plus 1. That is 2 plus 1. In 3 states you must construct this problem. Using the 3 states only you must construct the problem. First I approached A. So what I will be doing? Do of, these are the transition. Do of first state I will be taking, that is Q0, comma. Next, what is the element I approached? A. That you must write in the middle, comma. What is the element at the top of the stack? In top of the stack we are having only one element, that is z0. So just write z0 which will be equal to. So now since you approached A, until you finish approaching A, that is while you traveling from left side to right side, until you travel the last A, you must be in the same state itself. So from Q0 you will be going to Q0 itself. And now what you must do is, first you approached A, no? So that one you must write in the stack. Now what are the element in the stack? A, Z0. So you must write that one. A, Z0. After writing this one only, you must add the element to the stack and write. Otherwise you will be confused. So let's solve another problems also. You will be understanding much easily. Do of, what is the state? At present we are in Q0, comma. Next, what is the second element? That is small letter a. So small letter a, comma. What is in the top of the stack? Small letter a, which will be equal to. Now what I said, until you approach a itself, what you will be doing? You will be in the same state itself. So Q0, comma. After writing Q0, you will be adding a into the stack. Now this is the second a. So what is the updated stack values? A, Z0. This like simple. Next, we are approaching third A. So what we will be doing? Do of, at present which state we are in? Q0, comma, A we approached. Top of the stack also I am having A. Now, since we approached A itself, so you must not change the state. That will be Q0, comma. So now after writing Q0, you will be adding that element into the stack. Now, what are the elements in the updated stack? A, Z0. Now, you are moving into B. When you are moving from A to B, that is, there is a change in the element, you must change the state also. So you must only change the state, not change the values in the stack. That is, you are not supposed to update the B value in the stack. You are only allowed to change the state. So now if you see do of, at present I am in Q0. Now at this state I will be moving to Q1. So this is the second state I am using. In that 3 states that I am allowed to use, Q1 is the second state. So now what you approached, small letter B, comma, in the top of the stack I am having A. Now when you came from Q0 to Q1, and if you see here, we will be having two situations. One, when there will be same number of A and same number of B. That is A power n, B power n. When n value will be equal to 1, 1A, 1B. When n value will be equal to 3, 3A, 3B. Like that. So if you see here, we will be having equal number of A's and B's. So in this situation, what we will be doing? We will be in the same state itself. When you approach A also, you will be in the same state. When you move from A to B, you will change the state. Until you move from B to another state, you will be in the same state itself. So, but when there will be change in the number of A and B, that is A power n, B power 2n means, here, how many number of A are there? Twice the number of B's are there. That is, the change in the number of the A's and B's will happen. So, what you will be doing is, you will be having two situations. One will be even and another one will be odd. That is, you will be considering one state as even and another state as odd, and you will be giving the connections to that. So I have solved it in the part 1. This is part 2. I will show. So you can see the part 1 video in the description or in the I button I will give. Now, if you see here A power n, B power n. So here same number of A and same number of B are there. So what we will be doing? When you are approaching A, you will be in the same state, and when you are moving from A to B, when you are moving from A to B, you will be changing the state, and until you will be in the B itself, you will not change the state until you move to the another element. So now, from Q0 I went to Q1, and I will be writing epsilon here. I will be writing epsilon, and I will not update any B in that stack. I will just pop out A. I will just pop out A because same number of A's and B's are there. So now I popped out and wrote epsilon here. Next, do of, at present I am in Q1, comma. Next I am approaching second B. So B, comma, in top of the stack I am having A, which will be equal to, what I said, same number of A, same number of B means B will be in the same state itself until you approach the last one. So that is Q1, comma, epsilon. When you wrote epsilon here, pop out the top of the stack. Next, do of Q1. At the present state we are in Q1. So this is the third B I am approaching, comma, B. In the top of the stack I am having A, which will be equal to, so Q1, comma, epsilon. So now I will pop out the last A also. Now 3A, 3B are over. So the last left is epsilon. When you approach the epsilon, that is the different element. So when you approach the different element, what you will be doing? You will be changing the state. So when you came from A to B, you change the state. When you are moving from B to epsilon, you will change the state. When both A and B values are same. So do of, now you are at Q1, comma, now you approach epsilon, comma, in top of the stack I am having Z0, which will be equal to, I am moving to Q2 because I approached the different element. Next, what you must write here? So in this step only, I will show the empty the stack method and final state method. If it is a final state method means, you will write Z0 directly here. Okay? If it is final state, Z0 will be written. Now, if it is a empty the stack method. So empty the stack method means, you will be emptying the stack. That is, you will be removing 0 and you will be writing epsilon here. Empty the stack method means empty the stack and write epsilon. If it is the final state method means keep Z0 as it is. Now after writing the transitions, we must write the PDA diagram. So now let's write here. So here we just used 3 states as we calculated at the starting. Q0, Q1 and Q2 are the 3 states. Q0, Q1, Q2 are the 3 states. Q0 is my initial state and Q2 is my final state. So final state enclosed within 2 circles and initial with the single arrow. Now from Q0 I am moving to Q0 itself, that is self loop. If I give AZ0 as the input, my updated stack will be AZ0. So A comma Z0 slash AZ0. A comma Z0 slash AZ0. Now Q0 to Q0 itself, that is self loop. If I give A and A as the input, AZ0 is the updated stack value. So A comma A slash AZ0. Next third one, Q0 to Q0 self loop. If I give A and A as input, A Z0. A comma A slash A Z0. Next Q0 to Q1. Now I am moving from Q0 state to Q1. B comma A are my input. Epsilon. Epsilon represent popping out the top of the stack element. So B comma A slash epsilon. Next Q1 to Q1 itself. Self loop. B comma A epsilon. So B comma A slash epsilon. Next Q1 to Q1 itself, that is self loop. B comma A epsilon. So B comma A epsilon is already written, no need to write it again. Next Q1 to Q2. Epsilon comma Z0 slash what is the element left in the stack, that is Z0. So this is the completion of problem. So hope you understood the topic, how to solve the PDA construction problem easily. If you have any doubt regarding this topic, please do comment below. And the part 1 video is given in description, you can check out. And if you liked the video, please subscribe and support us. Thank you.